All right. Couple of reminders. So the last quiz we took here on forward, if you wanted to earn some points back, come see me and I will allow you to earn half your points back on a quick conversation. Now, I have to warn you, Tuesday and Wednesday this week, I am gone in the afternoon because I'm going to Cadaver Labs. Okay, so don't show up Tuesday or Wednesday this week, or Tuesday, Wednesday next week to double check on stuff. Cool. So what that means is the last quiz we took, I need you by this Friday, if you choose to come on one of your off periods, and we share an off period. So come by this Friday. I'm off periods 4, 6, 7, and 8. Okay. I would imagine I bet you we share one of those. If we don't, talk to me individually, please. Cool? All right. So by this Friday, if you want to go over the last test, that'll be the last day. I'll let you come in and get half your points back, which is pretty generous. Some of you have still owe me a quiz or test or something. So let's get those made up, please. And again, I won't be here Tuesday and Wednesday afternoon, so 6, 7, and 8 on tomorrow, and Wednesday I won't be here. Cool? All right, so 110. So they had used Desmos on that list. Agree? That list is not a 5-number summary. There's way more than 5 numbers. And they want us, if you calculated that whole list, I'm not going to go plug it into Desmos. If you're having problems with Desmos, let me know. But I will tell you things on Desmos that it will tell us is Q1 is 19 and Q3 is 27. And I'll show you how to get to that if you're not sure how to get to it. But that's basically the top and bottom. And then they want us to find the lower bound and the upper bound. Okay, remember this is dealing with numbers. So I'm going to go, the lower bound is Q1 minus 1.5 times the IQR. What's the IQR again? Anybody? Thank you. Q3 minus Q1. Okay. So we plug this in. It looks like we're going to get 19 minus 1.5 times 8, because I believe the IQR was 8. Yeah, 27 minus, bless you. You get 8. So that gives me 7. And then the upper bound is going to be Q3 plus 1.5 times the IQR. So in this case, it's going to be 27 plus 1.5 times 8. So that's 39. Okay. So these two numbers define are where our outliers would exist. So to the left of 7, to the right of 39 is where the outliers would exist. Are there any outliers on this? It looks like 40, 61, and 76 would all be outliers because 39 is my top. There isn't any outliers at the bottom. There's nothing below 7. And then construct a modified box and plot. So number 2, yes is the answer. You have answer 40, 61, and 76 are outliers to the right. And then if you constructed a box and whiskers, basically it's going to look something like this. So this would be at, say, 10. This would be at Q1, 19. I don't even know what my median is. I didn't find it. Looks like about 21-ish. And 27. And then this last number here is like 31-ish. And then I have these dots out here. So that would be our 40, our 61, and our 76. Okay. So that's the first problem. Does that make sense? I'm going to go back on what I said. I'm going to do this on Desmos. because I want to show you how Desmos will find you those outliers without any problem. All right, Desmos. Calculate, graphic calculator. I need a volunteer, please. What are our values? I'm at the very top of the page. So 24, 19, 31, 27, 20, 19, 25, 22, 28, 10, 28, 29, 21, 18, 21, 17, 27, 76, 24, 20, 24, 18, 40, 22, 19, 18, 21, 20, 25, 16, 61, 23, 26. Cool. All right. Thank you so much. All right. So once I have my data plugged in, there's things I can do. We can do the box plot so we can see. And so remember, this is going to be X and mine shift 1. And then exclude outliers or include outliers is kind of the important thing to have on there. So if I take a look at our graph, so our graph at the 40, at the 61, and at the 76, those are the outliers. If I don't hit the exclude outliers, they make that line long, okay? Okay, you want to know what the outliers are, so make sure that you have that hit. And then the other thing that I heard people had questions on, how was I finding certain things? So if I type in stats of X shift 1, this will give me my min, my Q1, my median, my Q3, and my max. But notice the max that they gave us was the outlier. So at the end of Q3, so on our graph, we do have a 10 here, which I agree with. The Q1 is right here at 19. The median is 22. Q3 is 27. But then it says the max is 76, but it happens to be an outlier. Okay? So you might want to think about what this number would be. And in this case, it would probably be 31. Okay? But again, you might have to kind of guesstimate it. And then so I heard some people asking, how was I getting like IQR and stuff like that? IQR is the Q3 and the Q1 subtracted from each other. So 27 minus 19 is 8. And then you would use those two equations, the Q1 minus 1.5 times the IQR, and that would give us the absolute bottom limit that would include our data. And then the upper bound, the Q3 plus 1.5 times the IQR. So 27 plus 1.5 times 8. So 39 would be the absolute outlier there. Okay? Questions about what we did? We good? You're looking upset at me. What did I say wrong this time? Okay. Can you believe that a kid walked into my med class and was just jerking around? Like what kind of dorks are here that early to mess around in someone's class? Tell you what. I my sister didn't have kids because she'd probably have kids like that. I'm just kidding. All right, so let's move on. For problem number 4, 5, and 6, they give us the 5-number summary. So we have a min at 6, we have a Q1 at 26, median at 30, Q3 at 34, and a max at 44. Can I plug this into Desmos to see what the graph looks like? No, it's already the 5-number summary, so it's not going to plug into Desmos to do it. Okay, so important things that we want here, those will find us the IQR, which is Q3 subtract Q1. So that's 34 minus 26, which is 8. So if I want to find my lower bound, I'm going to go my minimum, or excuse me, my Q1 minus my IQR times 1.5. So on this one, it's going to be Q1 is 26 minus 8 times 1.5. And that's going to give us 14. My upper bound is going to be Q3 plus the IQR times 1.5. So that's going to be 34 plus 8 times 1.5. And that gives me 46. Explain why constructing a modified box plot is not possible in this situation. And let's see, hang on, one more thing. Is there any outliers in this data set? If so, identify them. So this would be an outlier to the left because it's less than the 14. But you can't construct a modified box plot because we can't see, well, okay, so if I try, let me try this. I'm going to try it, and I'm going to show you why it's not going to work. So if I had 6 here, which is an outlier, then I have this. So I know that this 44 would work as my max, and that checks because it's not an outlier there. I know that this Q3 is 34. I know this median is 30, and I know this Q1 is 26. What is this number? Because it's not 6. Okay? So we don't, even though we know what that limit could be, I can't, because our lower limit appears to be 8. Some people might put that at 8, but I can't guarantee that it is 8. Okay, so the minimum happens to fall as an outlier. So that's why I can't make this. This won't work. Okay? I feel like I'm rambling, and I apologize. Page 124, modified box plot. Find each of the following for the Oscar-winning females. So we're using the top. So the IQR for number 7 is 8. On number 8, the range is 80 minus 20, so 60. The median for the females appears to be 34-ish. Standard deviation, I can't tell from that. Upper boundary would be the 41 plus 1.5 times 8, so that'd be 53. The lower boundary would be 33 minus 1.5 times 8, so that's equal to 21. There are outliers. They appear to be around 61 guesstimating, about 73 guesstimating, and about 80, 81, somewhere in there. And the shape would be skew right. Why would the female's information be skew right on page 124? What is making it skew right? The outliers. Good job. All right. So that was basically, if you're here, I'm going to get you the credit for it. And a couple of you remind me that you walked in late so I can unmark you. So I need to go to 1-11, which is somewhere in this booklet. This is on page 25. This is 1-11. It says the ordinal data problem. Okay. So there are definitely some words here on page 25 that you would definitely want on your note card for the quiz that we'll have on Friday. Okay? Yes, other things can go on there as well, but it says they give us these opportunities as statisticians. They split quantitative data another way into nominal, ordinal, and scale. These are referred to as the levels of measurement, the amount of mathematical precision present in the data. All right. So let's see if we can put this into words I like better. So nominal, it says nominal level data emerge from the categorical. So this is categorical variables. The data are simply labels, gender, ethnicity, eye color, favorite TV show, all provide nominal level data because the data represents categories, measures, and center of spread makes no sense. You can't calculate the average eye color of a group. You can't calculate the average last name of a group of people. So nominal deals with categories. Okay? From categories, I can't make my 5-number summary. Okay? They could give us that and say, hey, we ran all this, and so we know what this is. But if we were just given a group of, we have 12 people in a group that have brown hair, we have 6 people that have blonde hair, and I'm just making this up. But that's nominal. So nominal is kind of a real broad spectrum of it. So ordinal level data places an outcome in a sequence, but have no measurement value beyond that. So you have an ACT score is an ordinal level variable. A student who obtains a score of 23 on the ACT knows they performed higher than the student who scores a 20, but we don't know exactly what the score is. So we've heard a 36 is the highest mark on the ACT. Agree? Okay. That 36 is not 100%. Does that make sense? What it basically does, and we're not quite here yet, but on a normal distribution of the ACT, we would have an average score. We would go out a standard deviation, go out another standard deviation, go out another standard deviation. So this region out here would probably be where the 36 would take place. So it's going to find out on a percentile where the 36 took place. Percentile would work if I were to basically break that x-axis into 0 to 100, that breaks us into the percentiles. Then you could break the percentiles even further down. So you're talking about a small amount of people. So basically somebody that's 3 standard deviations above the mean, or maybe 4 standard deviations above the mean, which you're talking about an incredibly small amount of people, would score a 36 on the ACT, but it is not a perfect score. Okay? So let's say the ACT was just 50 total questions. That would mean, if they did this with finding out which score would get the 36, if you got 44 or higher out of 50, you would get a 36. So the 36 doesn't tell you what your actual score was. You don't know exactly what you missed or didn't miss on the ACT. You just know that you scored higher than a certain percentile of the people. So, and I know the ACT isn't 50 questions, but let's just pretend it was. They're trying to figure out, hey, what scores fall in where. Okay? So ordinal data or level data processes no scale or no units. The measurements are merely an attempt to place an observations in the sequence, perhaps the highest to lowest. Let's assume a runner finishes 21st in a marathon. How far behind this runner was from first place? How close was was the 22nd runner? So the position to the runner, these are things that are important, but they don't necessarily tell a time. Like you might have somebody who runs a marathon and they get done in an unbelievable world record time, and second place might be 30 minutes behind that person. And then third place might be, a minute and a half behind second place, so on and so forth. And I'm just making this up. So the ordinal scale, you're kind of positioning stuff in a certain order, but you don't know the exact score itself that it would be. So like on the ACT, yes, if you were running a marathon, you would probably know your personal time, but when they were listing, hey, first place, second place, third place, fourth place, etc., the first, second, third, fourth, fifth place isn't necessarily assigning times, just who crossed the finish line at certain, first, second, or third. Then you have the Likert scale. And I think the Likert scale is the most abused thing in statistics. Okay? What do you know about if you're collecting data? I want yes, no. No notes? No book yet? Okay. The Likert scale, I want yes, no. And I want like 5 questions. Okay. Someone gives me a phone call saying, hey, we're not trying to. So they get me on the horn. And all of a sudden they start asking me questions, and they're going to give me answers like, do you strongly agree, neutral, disagree, or strongly disagree the following question? Do you think puppies are cute? Okay, so this is a Likert scale. So it's, you have strongly agree, neutral, disagree, strongly disagree. You can expand that out to a ridiculous amount of values. It doesn't really mean anything other than to collect data. So it says each survey question in a Likert scale has 5 selections. It doesn't have to have 5. We could have 10. Okay? The questions are 5 different outcomes. The responses are ordinal because the response provide an order, but they don't have a specific measurement value. Likert scales are used when you go to the doctor's office. They have if you went to your pediatrician, they're going to have a happy smiley face, a kind of a smiley face, a non-smiley face, a frowny face, and like full-on tears. And that's a Likert scale. And they're like, how much does this hurt, sweetheart? And get the kid to point to on it. It's a Likert scale. You're just trying to gauge different values, different ordinal values. Since ordinal level variables have no scale, no units, are merely a way to tabulate order, consider it inappropriate to find a mean, so you're not finding a mean from ordinal data. Median, however, you might be able to find. It's common that the means of the ordinal data be calculated and be announced. The average ACT score is well-known statistic that many school districts calculate and advertise. The calculation must be made to some degree of skepticism. The mean as a statistic assumes a degree of precision in the observations that may not be present. Means and standard deviation of ordinal data are inadvisable and should be treated with caution. Okay? Now, every beginning of the school year, we will talk about the ACT scores and where Cherry Creek High School fell. Okay? I'm just going to make up, this is not correct, but let's say Cherry Creek High School has an average of 25.1 on the ACT. I'm just making this up. The district as a whole has a score of 22.3, and the state has a 19.1. Okay? So looking at that, it probably goes to tell you that Cherry Creek High School is doing very well in comparison to the district. Cherry Creek High School is doing very well compared to the state. Okay? But I'm comparing Cherry Creek to a group, not another school. I'm comparing Cherry Creek to a much bigger group, the state. I can then compare Cherry Creek to the national average. Okay? So there's all different types of things that we can do to compare. And I know administration will, a lot of times, they will gloat about this, going, yeah, we got a 25.1 average score on the ACT. Oh, you have such good teachers and such good students. Yeah, yeah, we're kind of a big deal over here, but I think it's more you students are brighter than us teachers, so that's where it comes. So, um, this is not something you want to hang your hat on as an absolute. Where you hang your hat on it and brag about it is when you're at the top. Where you don't hang your hat on it and make excuses is when you're not at the top. Okay. Scale level data is quantitative and precise, often measured with instruments that we have well-defined measures. If you're measuring a variable of temperature, the units may be in degrees Fahrenheit. If you measure weight, the units may be in pounds. If you're measuring cholesterol level, units might be in millimoles per liter. Oh, that's tiny. Because the scale level variables at the highest level of precision, all statistics, mean, median, standard deviation, IQR, etc., are appropriate. In summary, many of our statistics require a level of precision in the measurement of the data. Mean and standard deviation are only appropriate for scale level variables. Median, IQR, and range are appropriate for ordinal. Okay, so ordinal, as we talked about, this is where the median, I just lost fit. Median, IQR, and range work here. Okay, that's for ordinal. Everything else is going to go with standard deviation and the mean. All right, I'm done talking. You're like, thank God. What you guys want for homework? 1, 1, 10, 1, 11. So let's do page 125 and 126. Carry through and do that. Have fun.